Okay, so in this video what we will do is we'll solve for the inverse z transform for a particular transfer function in the z domain, and that transfer function is h sub z is equal to 5 over 1 minus z to the minus 1 plus 0.09 z to the minus 2. Okay? Now, in order to get rid of the minus 2 in the denominator here, minus 1 here in this term, what we'll do is we'll multiply both the numerator and the denominator by z squared. Okay, so if we do z squared over z squared, that's nothing more than multiplying by 1, right? And so that's z squared over z squared times what we originally had, which was 5 over 1 minus z to the minus 1 plus 0.09 z to the minus 2. Okay, and what that yields then, or what that gives us, is 5z squared in the numerator, all right, times z squared minus z, okay, because that's z squared times z to the minus 1, plus 0.09, okay, as the denominator, all right. Now what we may do at this point then is we may factor the denominator into two parts there. So this becomes 5z squared divided by z times, and then that's z times, and so we have two sets of terms here, okay, once we factor. And so then this would be equal to minus z minus 0.1, and this one is z minus 0.9. okay, all right, so now that we have this, okay, what we will do from here then is, and remember this is h to the z, right? This is h to the z. So now in order to go to the z transform, or in order to do the inverse z transform, pardon me, what we need to do first is divide both sides by z, okay, and so that will end up giving us, or that will give us 5 to the z squared divided by z to the minus 01 times quantity z to the minus 0.9. okay, and so now we can use partial fraction expansion in order to figure out what our numerator needs to be here. So we have r over 1, z to the minus 0.1 here, plus r over 2, z to the minus 0.9. Okay? So now in order to use the z, or in order for us to do this now, what we need to do is we need to multiply both sides of this equation here by one of the denominators. Okay, so let's start off first by multiplying both sides of the equation by this here, okay, z to the minus 0.1. all right, so if we do that, we end up with oops, and I forgot to do this right here. Remember, we divided by z, right? So if we divided by z, this is no longer squared. Okay, this is no longer squared. All right, so this ends up being equal to 5z then times z to the minus 0.1 divided by z to the minus 0.1. okay, and then that is going to be multiplied by z to the minus 0.9, which is equal to then r1 z to the minus 0.1, okay, z to the minus 0.1, and that's plus r2 z to the minus 0.1 divided by z to the minus 0.9. okay, so if we look at this here, then this cancels with this cancels with this, leaving us with 5z, pardon me, over z to the minus 0.9 okay, which is equal then to what? Is equal to R1, okay, plus Z to the minus 0.1 R2 over Z to the minus 0.9, okay? Now let's see. If we let Z equal to 0.1, okay, for the entire equation that's left here, we end up with what? 5 times 0.1 divided by, so that's now 0.1 minus 0.9, so that becomes negative 0.8, okay, which is equal to R1 plus, if we put 0.1 in here, all right, what that ends up doing is making this entire term here 0. And so therefore then R1 is equal to 0.5 divided by negative 0.8. Okay. And this is equal to, that means R1 then is equal to negative 0.625. So now we've solved for R1. Okay. Now let's talk about R2. So for R2 now, remember we had 5Z divided by Z minus 0.1, Z minus 0.9, okay, which is equal to, remember it was R1 over Z to the minus 0.1. So I'm just rewriting everything so that we can see it easily here. Plus R2 Z minus 0.9. Okay. So now what we need to do is we need to multiply both sides here by the Z minus 0.9. So that's Z minus 0.9 times, and over here it's Z minus 0.9, so we're multiplying by that, Z minus 0.9, okay? And so once we've done this, okay, we know that this will cancel with this will cancel with this, leaving us then with 5Z, Z to the minus 0.1 is equal to R1 Z to the minus 0.9 times that anyway, times that quantity, divided by the quantity Z to the minus 0.1 plus, okay, these two cancel out, remember, so this is plus, so that's R2. If we let Z be equal to 0.9, so Z is equal to 0.9, okay, what we end up with then is we end up with our H of Z over Z again. So that would end up being equal to, as a matter of fact, let's just leave this off for now. So what that will end up being equal to then is 5 times 0.9 divided by 0.8, because that's 0.9 minus 0.1, which leaves you at 0.8. If we put 0.9 in here, this term here is going to go to 0, right? Because 0.9 minus 0.9 making this 0, 0 times that, which makes this all 0, plus R2. Okay? And so this then ends up being equal to 4.5 divided by 0.8, which is equal to R2, right? And so R2 then is equal to what? R2 then is equal to 5.625 when you calculate that out. Okay? So now that we got that, all right? So what this then means is that H sub Z divided by Z is equal to negative 0.625 divided by z to the minus 0.1 plus 5.625 divided by z to the minus 0.9. Okay, and so through partial fraction expansion, this is what we came out with. All right, and now we need to multiply both sides by z, okay, so that we can find now the the inverse z transform for this. So this becomes h sub z, all right, which is equal to negative 0.625 z divided by z to the minus 0.1, pardon me, plus 5.625 divided by z to the minus 0.9. Okay, and if we use our inverse or the Laplace transform table, we will find then that this becomes h sub n, okay, is equal to negative 0.625. And by the way, just take a few seconds to look that up in the table real quick. And I'll pause here for a minute, or a few seconds anyway. Okay, so now that you've located that this will end up being the following. Once we take the inverse Laplace transform, and we're taking it on each one of these terms now. So we're taking the inverse Laplace on this, which gives us this. We're taking the inverse Laplace transform on just this term here, which ends up giving us negative 0.625 times 0.1 raised to the nth power, okay, 0.21 raised to the nth power, times the unit step, okay, plus 5.625 times, oops, and I forgot to put my z over here. Okay, so remember we had to multiply both of these by z because these are terms on the right side of the equation here. So this ends up being then 5.625 times 0.9 raised to the nth power, and that's multiplied by the unit step. Okay, so this is the z transform of the original or this is the inverse z transform, pardon me, of the original transfer function in the z domain that we started off with. Okay, so if you have any questions, or if you would like to see some more transforms and z transforms and z transforms, please do check out my YouTube channel.